Welcome to the surface characteristics lesson. Whenever any process is used to manufacture a part, there will be always some kind of roughness on the surface.
It is quite convenient to check the ISO 1302 standard to understand completely this lesson. We know all materials have some roughness and waviness, but these concepts are not the same thing as you can see in the images. Roughness height is one of major parameters for quantification of surface roughness. There exist different patterns for defining roughness height. First, the average roughness index or height. It is the height obtained dividing the area between the roughness profile and the mean line by the evaluation length. Second, the mean peak to valley index. The distance of highest peak to deepest valley of a sample length is termed as peak to valley distance. Measure this peak to valley for 5 successive equal sample lengths to obtain R-Z. Different manufacturing processes yields different amount of roughness on the surface. So you could basically, the finer the finish and the tighter the tolerance, the greater the cost. Ideally, from a cost-impact point of view, it is best for the designer to accept the finish and tolerance capability of the primary process. This is the fundamental graphical symbol, and if it is used with complementary supplementing information, then no decision is taken as to whether removal of material is necessary for obtaining the specified surface, or whether it is not allowed to remove material for obtaining the specified surface. If removal of material by machining is required for obtaining the specified surface, a bar shall be added to the fundamental graphical symbol, as you can see in the figure. If removal of material is not permitted for obtaining the specified surface, a circle shall be added to the fundamental graphical symbol. Here you can see a summary of ISO 1302 standard. Two different ways exist of interpreting the specification limits of surface texture: the 16% rule and the max rule. This last one must be indicated. You can get more information of both at ISO 4288 respectively. The surface lay and the direction of lay resulting from manufacturing process are conventionally indicated with different symbols. Let's see now an example. The information about the process is the following. Let's consider a process that shall remove material with an unilateral upper specification limit. The machining process is turning. The roughness mean peak to valley value is 3.2 microns. We're going to use the 16% rule with a default filter window with a parallel orientation and the evaluation length of 5 sampling length. When you face a technical drawing, you must take into account that you can find different symbols that have changed throughout time. Let's see now how to put the symbols on the drawing. When the same surface texture is required on any surface of a workpiece, on a technical drawing, a circle is added to the complete graphical symbol illustrated in the figure, and the symbol shall be placed near the title block of the drawing. If we had the same surface texture on any surface of the part except a specific surfaces, we would indicate the specific symbols inside parentheses. We can use leaders to reach some surfaces. The general rule is that the graphical symbol, together with the complementary information, shall be oriented so that they can be read from the bottom or right-hand side of the drawing, according to ISO 129. And that's all for today. We'll continue in the next lesson.